All right. So we're going to pick off just right where we left off the last time. I'm even going to sort of pick off on the same page of notes, just because we're really just continuing with the same ideas. So we'd like to do a couple with carrying and borrowing. So the carrying will happen if we do addition, the borrowing will happen if we do subtraction. So this is related to carrying, oh my gosh, carrying and borrowing in just like whole number addition and subtraction. So for example, right, if I had something like 308 and then I'm adding, right, 97, what does this look like as sort of stacked addition? Well, 8 and 7 is 15, but I mark the 5 here and I carry the 1 up. So as this column gets to be too big, I just carry the next digit up. 1 and 0 and 9 is 10, so 0 comes down and 1 comes up, and then 1 and 3 is 4. So I'm carrying my sort of overflow values, right? If I get sort of something that the result that's bigger than 10, I guess if I get a result that's bigger than 9, 10 and up, I have to sort of carry that second digit, that digit in the tens place, up to the next place value in my arithmetic. So there's a similar kind of approach that we're going to take if we have sort of mixed numbers and we're adding together. Let me sort of put some values here. Let's do something like 6 and 4/5. Let's add it to 2 and 2/3, something like this, right? What's happening here that wasn't necessarily happening in the example above, right? 3/8 and 1/6, those are both kind of less than 1/2. So when we add them together, we know we're going to get a fraction value that's less than 1. What's going to happen here is, well, the opposite. So 4/5 and 2/3, both of those are bigger than 1. So when I add those fraction values together, I'm going to get a result that's bigger than 1, right? If two things are bigger than 1/2 and I add them up, I'm going to get something that's bigger than 1. Let's not get too far ahead of ourselves, right? Let's do our LCD. For 3 and 5, they don't have any common values, right? 3 and 5, so we're just going to have to use 15, the product of them together. 3 times 5, 2 times 5, 5 times 3, 4 times 3. Again, not doing anything to rewrite the whole number, so this is 6 and 12/15 plus 2 and 10/15. So if I just sort of add normally, if I just sort of add by type, 6 and 2, right? That's going to be 8. 12 and 10, right? 12/15 plus 10/15. So what starts to happen here is I get 22/15 is my fraction value. And so what I'm kind of ending up with here is 8 is a whole number, and then a fraction that is actually bigger than 1, a fraction that sort of is an improper fraction. So I'm getting this kind of hybrid number, right, where it sort of is a mixed number, but then the fraction itself is an improper fraction. That's not really anything. I mean, we really need to be sort of singularly an improper fraction or a mixed number. We don't want to be both at the same time. That's not really anything. So what we're going to do is look at the issue, which is really this 22/15, right? This is just sort of too big. So 22/15, I mean, that would really be 1 and 7/15, right? If we sort of converted that into its own mixed number. So this result here, right, is, well, 6 and 2 is obviously 8. And then 22/15, well, that's really 1 and 7/15. So all I'm going to do is just say, okay, well, I'm just carrying this extra 1 whole, right? Right, 22/15 becomes 1 and 7/15. So the extra 1 whole, I should just add to the 8, right? I'm just sort of carrying it up and over in the same way that you're doing when you do this sort of, old-fashioned addition, right? So 8 and 1, this is really going to be sort of 9 and 7/15, right? My kind of final answer here. I just carry the extra 1 up, right? Sort of convert it out of an improper and sort of back into a proper fraction, and just carry the whole numbers, right? Whatever my sort of whole number is going to be, just carry that onto the whole number that's already there. In theory, I mean, this is a situation you could avoid if you converted everything into an improper fraction. But again, right, I mean, the limitation is you're going to be doing 6 times 15 plus 12. You're going to be doing 2 times 15 plus 10. 2 times 15 plus 10 is not that bad, obviously, but like, I don't know, 6 times 15 plus 12. You know, it's certainly not one I know off the top of my head. 102, I'm pretty sure, but like, you know, whatever, that's neither here nor there. And then having to sort of divide those things by 15. So it's definitely a matter of personal preference. My own personal preference is to do this sort of borrowing move rather than scale these guys up into, you know, 100, 200, 300 kind of numbers, you know, 60, 70, 80 kind of stuff. I'd love to not necessarily have to do that and then, you know, do division by 15 in the end with something that ends up who knows where. That doesn't sound great. Let me show you a subtraction example, sort of working from similar principles, right? So sort of recall, right? For subtraction, you know, sometimes we had to subtract and we have to do like a borrowing. So if I had, you know, 104 and then I'm trying to subtract away, you know, something like 86, right? I know the result here is going to be a positive number because 104 is a bigger value. That said, if I go digit by digit, I run into this issue of, well, you know, kind of 4 minus 6 would give me like a -2. You know, we're not going to write -2 down here. So the idea is I borrow, right? I'm going to call this 14. What I need to do is I need to borrow from the digit above it, right? In theory, this is a 0. So that actually has to go all the way down to a 9, and then I sort of borrow from here. In some sense, this is a 10, and I'm borrowing 1 away from it, and it drops down to be a 9. So then this leaves me, well, 14 minus 6 would leave me with 8. And I have 9 minus 8 would leave me with 1. So the difference here is 18. You can kind of intuit that. These numbers aren't too far apart. But to make this work just sort of conceptually and just sort of numerically, we need to do this sort of borrowing move. So what would a similar kind of idea look like with mixed numbers? Well, let's do something where we know the result we're going to get, right? Let's do 12 and, I don't know, what the heck haven't we used yet? Let's just do like 12 and 1/4. Let's, you know, subtract 3 and 5/6. So I know 12 and 1/4 is bigger than 3 and 5/6. I know I'm going to end up with a positive result here. In theory, right, you know, this is a little bigger than 12. This is a little less than 4. 12 minus 4 would be 8. I should get something a little bigger than 8, right? That's kind of where I should end up. But obviously we need to sort of go through the steps here and sort of make this work. Step 1 is going to be, as always, our LCD, right? So LCD for 4 and 6. Well, you know, what do they have in common? They kind of have a 2 in common. You know, 8, 12. 12 is going to be it, right? 6 times 2 and 4 times 3. So we'll take that. We'll scale these guys up. So this is going to be 12 and 3 over 12 minus 3 and 10 over 12. So you can kind of anticipate, if you were going to set this up as a subtraction, you can kind of anticipate pretty quickly that there's maybe going to be an issue, right? You know, if I kind of group these by type, this is going to be kind of right 12 minus 3, and then this is going to be 3/12 kind of minus 10 over 12. So if I kind of just do what I was doing, I'm going to end up at, you know, 9, but then this is going to be like kind of plus a negative, what, 7/12? So this is like a whole number, but then a negative fraction, you know, 9 and negative 7/12. I mean, kind of conceptually, yeah, I mean, I'm writing it with an addition here. because it just would look so weird to even write it otherwise, right? You're going to write 9 and then kind of negative 7 over 12. I mean, it doesn't even make any sense, right? Like, what's even happening there? Like, this is no good. But, like, how am I supposed to do this subtraction and avoid this? How am I supposed to not get a negative here? I mean, I've only got 3 over 12, and I'm trying to subtract away 10 over 12. Let's reboot this for a second. So this is 12. 3/12 minus 3 and 10 over 12. So let's take a step back. Let's look at this 12 and 3/12, right? So 12 and 3/12, what's really going on here? So this is sort of, right, 12 plus 3 over 12. What I can do here is if I look at 12, the idea is I'm going to borrow from the bigger values. So 12 would really be like essentially 11 and 1, right? 11 plus 1 is 12. And then I have this 3/12. So what I'm going to do is if I just break one whole number off of there, and then I want to kind of regroup it with the fraction. So this would kind of be like an 11 plus 1 and 3/12, right? I'm kind of doing the opposite of what I did before when I sort of carried over the excess. I'm trying to create a bigger fraction. So I can borrow one whole number from 12. I can sort of cut it down to 11 and sort of take one off of it, right, and attach it to the fraction. Then this would get me, right, 12 times 1 is 12, right, plus 3 is going to be 15 over 12. And then just carry my 11 down. So what I end up with here is, right, instead of 12 and 3/12, I can write it in the sort of extremely awkward notation 11 and 15/12. We literally just said that this is not really a good thing to have a mixed number sort of mixed with an improper, but it works for us temporarily in as much as it will sort of make this subtraction run more smoothly. So if I kind of take this and I transport it back up to here, right? So instead of using 12 and 3/12 and subtracting away 3 and 10 over 12, let me use my new version. So 11, 15 over 12. And if you think of this even a little more quickly, you're saying, okay, what am I doing here? I'm taking 12, I'm taking one of my whole values, breaking it into 12s, that would be 12 over 12, adding it to the 3 that I've got. So 12 and 3 is 15. I'm then going to subtract away 3 and 10 over 12, right, just like I was doing before. That leaves me with a better setup where I can do 11 minus 3 is 8, and then I can sort of get my fractions going side by side, right? 15 over 12 minus 10 over 12. That's going to leave me with 5 over 12. So 11 minus 3 is 8, and then I'll get this sort of new fraction left over, 5/12. I'm left with a nice answer, right, that sort of is a mixed number. It's not anything that I need to sort of do any conversions on. It sort of is in the form that I'm after, and everything's looking pretty good. So that's what you would do to sort of do borrowing. It's not something you need to do every single time in these problems, but it's a thing that can happen. And that's how you do it. Again, in theory, you can always revert and just sort of do these as improper fractions, convert them into impropers, and then just work with the big numbers. That should work out. I mean, that is fine. That's a totally reasonable course of action to do. It should work. It's just that if you're trying to avoid those bigger, 150, 200 something kind of numbers, you have to deal with this borrowing stuff. But that's the idea, and that's 4-6.